Paul Jerome. Alright, so let's ask the question, is this factored? Class, is this factored? Yeah, because it has those parentheses. Does that make sense? Number 2. Andrea. Let's get a basic graph. Now, you could do what we did in the warm-up, where x plus 2 means 2 of those parentheses, right? And then you can FOIL and do the box, and then multiply that by again. Yes, that'll give you the exact answer, but I just kind of want a quick one. The number up here, if you don't have an exponent, is a 1. And essentially, this is just x to the first power. So again, instead of multiplying all the way through, this one will be x squared. Do you see that? And if I multiply those together, I get x to the, what? Third power. Well, what does x to the third power look like? It's an odd degree polynomial. X to the first is also an odd degree polynomial. In its end behavior, the odd degree starts down, ends up. So this graph is also going to start down, ends up. So that's just what our basic graph might look like. Okay? Number 3, Gabriel. Multiplicity. Let's make a chart. Zeros, degree, or its multiplicity, and then is it going to do a kiss or a shoot through? Alright, Gabriel, what does it say underneath multiplicity? Zero product rule. So let's go ahead and show you what the zero product rule is. Basically what it means is you just take this factored form, x minus 3, and you set it equal to z, 0. And when you solve for this class, you get what? X equals 3. So one of my zeros is x equals 3. So a big idea of what we're learning right now is x minus 3 is the same thing as x equals 3. Same thing. Okay? Let's look at this right here. Its degree or multiplicity is what? 1. And is 1 an odd or an even? And what do you know about odds? Odds you shoot through. So write ST. Okay, let's look at the other one now. X plus 2. Let's set it equal to 0. And when you solve for that class, you get what? X equals negative 2. So let's write that. X equals negative 2. What's its degree? 2. Is that an even or odd number? And what do you do at evens? You kiss. So we've done the zero product rule, and we've done the shoot-throughs and kisses. Okay? Number 4. Iser. Are there any transformations, or what was the next part? Any shifts? Basically, you're not generally going to see these. It would basically mean a minus 6 out here, or a negative 1/3. Okay? And then number 5. Vanessa? Let's graph it. Okay? So, get out your ruler, if you haven't already. Let's plan ahead. On my x-axis, I need to have enough of my graph to have a 3 and a negative 2 on the x-axis. If you have highlighters, they're helpful. So on my x-axis, I'm going to mark positive 3. And I'm also going to mark on the x-axis where it is -2. If you want to, you can write those numbers there. Not needed, but it might help you. Okay, remember how we talked about the basic graph? How my graph is going to start down and end up? Let's make that on our graph. Starts down, ends up. And we're going to go left to right. Everyone say left to right? Now, the basic graph, if it does have a negative sign, it would just flip those. And we'll do an example like that. Alright, so we're going to start here at my arrow. And as I approach the pink, what are we going to do at the pink? We're going to kiss or bounce off. So as I start here, you're going to go towards there. You kiss and run away. And then what do we do at 3? I'm going to go through this, and I need to end up at the blue. Okay? So you have a turning point here, which we learned yesterday. And now you have basically sketched a basic graph here. Now you could do other things, such as like find the y-intercept, make x equals to 0. That would be at -6, so it should have been pulled down a little bit further. And probably on your next quiz, you're not going to have a calculator, but I just want to show you that we are getting the right one. So you can just type it in factored form. X minus 3, X plus 2, zoom 6. And you can see that our graph looks very similar. Oh, you can't see anything. And you'll notice that it starts down, bounces, shoots through, and ends up.